In this video, we're going to use Einstein's equation to solve problem. So let's begin by understanding what Einstein's equation is all about. If you have a nucleus X decaying to give Y and R, okay, the difference between the mass of X and the combined mass of this product, that gives you delta M, which is the mass defect. So let's look at how we apply this equation to solve problems. In this question, we are told that in a thermonuclear reaction, the total initial mass is this, and the total final mass is this. The energy released in the process is not known. We are given speed of light. So let's give it this approach. Let's call the initial mass M1. So we're giving M1 to be 5.02 multiplied by 10 to the power of negative 27 kg. Then we are given the final mass M2, which is that of the product, 5.01 multiplied by 10 to the power of 27 kg. Okay, again we are giving speed of light to be 3 times 10 raised to the power 8 meters per second. So what we can get here is the mass defect. We use these two to get the mass defect, which is going to give us delta M. So delta M, which is the mass defect, is going to be M1 minus M2, because M1 is higher than M2. Okay, and that will give us, going to this side, M1 minus M2, that will give us our delta M to be, our M1 is 5.02 multiplied by 10 to the power of negative 27 minus M2, which is 5.01 times 10 to negative 27 again. So our delta M will be 5.02 minus 5.01, then multiplied by 10 to the power of negative 27. So the mass defect, when we do this subtraction, will give us 0.01 multiplied by 10 to negative 27 kg. So we have gotten our mass defect as this. So I can still write this as delta M being 1.0 times 10 raised to the power negative 29 kg. So it's still the same thing. So I've gotten my mass defect, and we're now in good position to get the energy. So we know that energy E is delta M C squared. So energy will be delta M is 1.0 multiplied by 10 to the power of negative 29, then times C squared. That will be 3 times 10 to the power 8, then all squared. So the energy will be 1.0 multiplied by, this will be 9, multiplied by 10 to the power of 29, multiplied by 9, multiplied by 10 to the power of 16. And that will give us energy to be equal to 1 times 9 gives us 9. So that's 9.0 times 10 negative 29, then plus 16 by indices. So the energy will be 9.0 times 10 raised to the power 13 joules. So this is the energy that is released in this process. So energy released is that, and that corresponds to option A in this question. So that is the answer to this. Another interesting question. This question says, in a nuclear reaction, the total mass of the reactant is this, while the total mass of the product is this. Question A says, calculate the mass defect. B says, given that the energy, calculate the energy released in mega electrovolts. This is mega electrovolts. It's also a unit of energy. So let's begin this way. Solution. All right, we are given the mass of the reactants. Let's call it M1. M1 is given to us as 2.0150 U. This U is atomic mass unit. All right, and the mass of the reactant, the product, are given the mass of the products to be 2.0140 U. Okay, so from here we'll be able to get our mass defect. our delta M, which is M1 minus M2. So let's compute our mass defect and see what we have. So delta M, our mass defect, will be equal to M1. Our M1 is 2.0150 U minus M2 2.0140U. So our delta M will be, when we do the subtraction, this will be 0.0010U. So this gives us the mass defect. All right. Now that is this. Then going to the second part of the question, which is to calculate the energy released in mega electrovolt, given that one atomic mass unit releases this amount of energy. So if one atomic mass unit releases 931 mega eV, then what energy should this mass release? All right, we know that energy is delta mc squared. Okay, so we are already given what 1 uc squared. That is this is 1, of course. So 1 atomic mass unit multiplied by c squared is equivalent to 931 mega ev. So that is 1. So what are we going to do to get this? So to get the energy that this will release, E will be this very mass, which is going to be delta M, multiplied by the energy that this will release, which is 931 mega ev. Okay, so this energy will be equal to 0.001. Okay, I wouldn't write U again because 1 U combined with speed of light is equivalent to this. So just say times 931 mega ev gives us 0.931 mega ev. So this is the energy that will be released by this mass.